Let us look at question number 41 now, students. MgSO4 is soluble while BaSO4 is insoluble in water. This is because. So if we talk about the dissolution of solids in water, so we have, let's say, MgSO4. So this MgSO4 solid will first convert into Mg2 plus gaseous and SO4 2 minus gaseous, and then these will be hydrated to form Mg2 plus aqueous and SO4 2 minus aqueous. So students, we can clearly see that there are two steps involved. The first step involves the breaking of the solid into its gaseous ions. The energy involved is known as the lattice energy. Whereas the second step is the dissolution. So the hydration energy will be released in this step. So the solubility of species depends upon a combination of these two factors. So there is a lattice enthalpy factor and then there is a hydration enthalpy factor. Okay. So if we talk about Mg2 plus and the other ion which will be formed is Ba2 plus. So this Mg2 plus is more hydrated than Ba2 plus because it has a high charge density. So due to this extensive solvation, the hydration enthalpy of Mg2 plus will be greater as compared to Ba2 plus ions. Now if we compare the lattice energy factor, the lattice energy of MgSO4 will also be greater than that of BaSO4 because of the small size of Mg2 plus ions. But it is a fact that the hydration enthalpy is greater than the lattice enthalpy, which accounts for the greater solubility of MgSO4 as compared to BaSO4. So students, the answer which you are looking for in this question is the third option, which says that the hydration energy of Mg2 plus compensate the lattice enthalpy factor, but it is not possible in BaSO4. Let us look at the next question now. Question number 42. The IUPAC name for the given complex is. So if we talk about the oxidation number of the species given to us in this complex, we have NH3 whole 5, Cr bridged by OH, Cr NH3 whole 5, and the whole complex carries a charge of 5 positive. So this hydroxide ion is present in a state of -1. So it is obvious that both these chromium ions shall have a state of +6, and because of the symmetry, both this chromium will individually be in a state of +3. So if we talk about the IUPAC name of this structure, we'll have a mu hydroxido because of the bridging. So it is given to us in all of these options. So we'll have mu hydroxido bis, as there are two of these same part present. Bis pentaamine chromium 3 ion. So if you look at the options which is given to us, correct answer to this question is option 4. Let us look at the next question. Question number 43. We have been given a reaction sequence in which an unknown compound X is allowed to undergo reaction with K2CO3 in presence of air, and it is heated to form a compound Y. That Y is further allowed to react with Cl2 to give us a pink color compound Z. So students, this reaction sequence is used for the preparation of KMnO4. So in the first step, there is alkaline oxidative fusion of MnO2. In which the MnO2, it reacts with K2CO3 in presence of atmospheric air to give us K2MnO4, in which Mn is present in a state of +6, and then this K2MnO4 is allowed to react with Cl2 to give us KMnO4. So if we talk about the color of the species present, MnO2 is black in color, K2MnO4 is green in color, and the color of KMnO4 which is given to us in the question is pink purple. So if we look at the options which are given to us, we can clearly see that we have to mark option 1 as the correct answer to our question. Let us look at the next question. Question number 44. Which of the following complex ions obeys Sedgwick's effective atomic number rule, which is also known as the EAN rule? If we talk about the first option, we have FeCN6 3 negative. So the Fe is present in a state of +3. So it has 23 electron of its own, plus the 12 electron will be donated by the cyanide ions, and it is going to have an effective atomic number of 35. So this does not follow effective atomic number rule. If you look at the second structure now, we have CO, CO3 and NO. So the whole complex is neutral. So we can assume that CO is present in a state of +0 in this case. The atomic number of CO is 27. So we have 27 electrons of CO, plus we have 6 electrons coming from carbonyl. So 27 plus 6, and then NO is a 3 electron donor. So this is going to give us a total of 36 electrons. This structure follows the effective atomic number rule. If you look at the third option now, we have chromium NH3 whole twice, En whole twice, 3 positive. So we can see that chromium is present in a state of +3. So it is going to have 21 electron of its own. Then we have 2 ammonia ligands. They will be donating 4 electrons to the complex. And if you talk about En, En is a bidentate ligand. 1 En donates 4 electrons. So 2 En will donate 8 electrons to the system. So we are going to have a total effective atomic number of 33. This also does not follow EAN rule. And if you look at the last option now, we have Ni En whole twice, NO whole twice. So in this case again, Ni is in a state of 0. So it has 28 electrons of its own, plus the En will donate 8 electrons and the NO will donate 6 electrons. So we have 28 plus 8 plus 6, which is equal to 42. So this also does not follow the effective atomic number rule. So out of these 4 given complexes, only the second complex follows the EN rule, and we have to select option 2 as the correct answer to our question. Let us look at the next question now. Question number 45. KMNO4 and K2Cr2O7 are intensely colored compound because. So students, we know that KMNO4 and K2Cr2O7. So Mn is present in a state of +7 and Cr is present in a state of +6. So both of these species have S0 D0 configuration, and these are colored because of the charge transfer from the ligand to the metal. So we have LMCT, in which ligand to metal charge transfer occurs. So looking at the options, we have to select option 3 as the correct answer to our question. Let us look at the next question now.